In this video, we're going to solve a series of questions involving geometrical application of vector products. Now, before we go through the series of questions, let's look at this point, or let's take note of this point. It's very, very necessary. Now, the first point is the area of a parallelogram with adjacent side A and B is given by the magnitude of A times B. Now, the second point is the area of a triangle with adjacent side A and B is given by the half of the magnitude of A times B. And the last point is 2 points or two vectors A and B are collinear, which is linear dependent if A times B is 0. Now, let's look at the questions. Now, in our first question, we have two vectors, A, which is equal to 2i plus 3j plus k, and B equal to I minus 2j plus 4. We are going to find the vector product A times B. Now, how do we do this? We are going to go through this step by step. So let's look at it. So the first step that we need to do is to write down our determinants. So with the first step, so step 1, write down your determinants. So write down determinants. So with the determinant, we have A times B equal to, we have our I here, we have our J, then K. Then we have 2, 3, 1, 1, negative 2, 4. Now this is our determinant. So the second step here is to calculate the determinant. So second step is to calculate the determinant. So calculate the determinants. So how do we calculate the determinant? So we have A times B equal to, so I multiplying 3.4, that is times, minus 1 times negative 2, then minus J 2 times 4 minus 1 times 1, then plus K multiplying 2 times negative 2 minus 3 times 1. When we simplify, we should get I multiplying 12 plus 2 minus J 8 minus 1 plus K minus 4 minus 3. And lastly, we should get 14I minus 7J minus 7K. So this is our determinant. So that is the answer for the product A times B. Very easy. Now let's look at our second question. In our second question, we're going to verify that the vector product of two parallel vectors is 0, given that the vectors A 4i minus j plus 2k and B 8i minus 2j plus 4k. So let's do that with step-by-step solution. Now the first thing that you need to do is to verify something. Now if you look at the vectors here, you can see that B is equal to 2a, which means that A and B are parallel. You can see that from the question. Now, the second thing that you need to do is to write down the determinants. So how do we write the determinants? So So this is step 1. Step 2, write down the determinant. So with the determinant, we have A times B equal to I, J, K. Then 4 minus 1, 2, 8 minus 2, then 4. Right. Then when you are done, you calculate the determinant. So with the determinant, we have A times B equal to I multiplying, so let's say this big bracket, negative 1 multiplying 4 minus 2 multiplying negative 2, right? Then we have minus J multiplying 4 times 4 minus 2 multiplying 8 plus K multiplying 4 times negative 2 minus 1 multiplying 8. Then we have this. Now when we simplify it, we should get I multiplying 4 negative 4 plus 4 minus J 16 minus 16 plus K negative 8 plus 8. And when we do it, we should get 0I plus 0J plus 0K. And this is the answer for this question. Very easy. You can see this is very, very easy to do. Let's look at our third question. So now our third question, we are going to show that the magnitude of the vector product gives the area of the parallelogram formed by the vectors A, which is 3I plus J, and B, I plus 2J. So with this one, we are going to go through step by step for you to understand it. So the first thing that we need to do is to write the determinant. So write the determinant. So let's write the determinant. A times B equal to I, J, K. 3, 1, 0, 1, 2, 0. So this is our determinant. Then we will calculate the determinant. So that's the second step, calculate your determinant. So with our determinant, we have A times B equal to I multiplying 1 times 0 minus 0 multiplying 2 minus J 3 times 0 minus 0 times 1 plus K multiplying 3 times 2 minus 1 times 1. And if you simplify, you should get I multiplying 0 minus J multiplying 0 plus K multiplying 6 minus 1. And your final answer should give you 5K. That is A times B, which is our determinant. Now, when you are done with it, the next step that you need to do is to calculate the magnitude of A times B. So the magnitude of A times B is the square root of 0 squared plus 0 squared plus 5 squared. And when you do it, you should get, so we should get 5. So the area of the parallelogram is 5. Very easy. Very, very easy. Now let's look at our last question in this video. So with our last question, we are given two vectors, A, which is 2I plus J plus 3K, and B, 4I plus 3J minus K. Now we are going to find the sine of the angle between A and B using the vector product. So with this one, we are going to go through step by step. So the first thing that we need to do, so step 1, we write down our determinant. So with our determinant, you can pause the video and try to do this question. So we have A times B equal to, with our determinant, we have I, J, K. We have 2, 1, 3. We have 4, 3, negative 1. Then the second step is to calculate the determinant that we have written here. So second step, the determinant of that. So with the determinant, we have I multiplying 1 dot, which is multiplication, multiplying negative 1, minus 3 multiplying 3, then minus j multiplying 2 times negative 1, minus 3 multiplying 4, plus k multiplying 2 times 3 minus 1 times 4. And when we simplify, you should get I multiplying 1, negative 1 minus 9 minus j, negative 2 minus 12, plus k multiplying 6 minus 4. And lastly, we should get negative 10i plus 14j plus 2k. So this is our determinant. Now when we are done calculating our determinant, then we move ahead to calculate the magnitude of a times b. So the third one is to calculate the determinant, the magnitude. So the magnitude of a times b. So with that, we have the root of negative 10 squared plus 14 squared plus 2 squared, and negative 10 squared is 100 plus 14 squared is 196, 2 squared is 4, and we should get root of 300 when we add them together. And when we simplify it, we should get 10 root 3. Right, so we are done calculating our magnitude of a times b. Now when we are done with this, we move ahead to calculate the magnitude of a and b separately. So the magnitude of a, so with just a, we will have the root of 2 squared plus 1 squared plus 2 squared, and we should get root of 4 plus 1 plus 4, and finally we should get root 14. And the magnitude of b, the root of 4 squared plus 3 squared plus negative 1 squared, and we should have 16 plus 9 plus 1, and finally we should get 26. And lastly, when we are done with all this, then we find the sine of the angle between a and b. So with the sine of the angle is the magnitude of a times b on the magnitude of a multiplying the magnitude of b, and with that we should get, so with the magnitude of a times b, we got 10 root 3, and with the magnitude of a and b, we got root of 14 multiplying the root of 26. And when we do them, we should get 10 root 3 on root 364, and finally we get 10 root 3 on 2 root 91. Right, you can leave it like this or break it down as well again. So with this one we get 5 root 3 on root 91 simply. So this is the sine of the angle between a and b simply. So this is the end of this video. Watch out for my next video. Thank you for watching. Bye.